A barometer is an instrument used for measuring barometric pressure. The barometric pressure is a measure of the atmospheric pressure. The weather reports usually report the current atmospheric pressure and indicate whether the pressure is rising or falling, or whether it's steady. A change in pressure is usually associated with a change in weather. It may be a low pressure moving into the area, or a high pressure, usually bringing good weather. And so being able to measure changes in pressure is then a goal of this particular demonstration. I've got several different bottles here. I've got one bottle filled with just plain water, and then I've got a two-hole stopper here, which goes into this bottle, and then a second bottle fits on the one-hole stopper at the top, which is then supported in the clamp. If you don't have the appropriate size stopper, you can also make one using the bottle cap, punching a hole in it, putting the plastic tube inside the hole, and sealing it with a glue gun, hot melt glue. And then you can use this and put the other end through the two-hole stopper. So either way it can be used. To assemble the apparatus, we support it in the stand, and we want to make sure that the stopper is in tight, so to form an airtight seal. You can move the clamp up a little bit to support the upper bottle. Now what we want to do is to get the water solution in this range between the two stoppers. To do that, I attach the second tube, and so I can suck on this and actually suck some of the air out of the bottle, and we can see it bubbling through here when I do that. So let's try that. And you can see the water level starting to rise here. We want it somewhere in the middle. There. If the bottle is sealed properly up here, then the level of the water in the tube here should stay constant. The only problem is that it is very temperature sensitive, because a change in temperature will cause the air in our upper flask to expand or contract. And so it's a good idea to keep a thermometer nearby to record the temperature as well. To demonstrate the effect of a change in pressure, we can then impose a pressure on the liquid here simply by blowing on the tube, which causes the liquid to go up, or sucking on the tube, representing a lower pressure, which causes the liquid to go down. So you can keep this apparatus set up in your classroom together with a thermometer. Students can measure then the height of the water column. They should also record the temperature. If there's a change in temperature, that obviously will also affect the volume here. The volume of air is fixed in here, so the only way that that volume can change if the temperature stays the same is if there's a difference in pressure. If the pressure is greater, it actually forces the water up the tube and compresses the air slightly in the upper flask. If the air pressure is reduced, then the pressure will be slightly greater in the flask, allowing the water to go down, representing then a low pressure. Many homes will have a barometer such as this one here, which is known as an aneroid barometer. The barometer itself has a metal diaphragm a sealed metal diaphragm inside the mechanism. And you can often see that right in that center hole. There's actually a round diaphragm in there, and it is sealed, and when the air pressure changes, that diaphragm will move in and out, so it goes in or out very slightly, and that mechanical motion is then amplified through a series of levers and eventually causing this dial then to rotate, indicating a change in pressure. Now, I can change the pressure a little bit by blowing into a hole at the back of the barometer. So when I blow in, you can see the needle moving to a higher pressure. When I suck, so I lower the pressure, the needle then records a lower pressure. And so you can hang this on the wall and monitor the air pressure. The mechanism is designed so that it's not temperature sensitive like the barometer that we just built.